May 24, 1944. North Atlantic, 180 miles west of Ireland, 14:37 hours. The USS England trembled as depth charges rolled off her stern, each one set to detonate at different depths. Destroyer escort, 6:35. A small warship, barely 300 feet long, hunting German U-boats in the most dangerous waters on Earth. Below deck, in the suffocating heat of the sonar room, Petty Officer Second Class Robert Martinez pressed his headphones tighter against his ears. The modified sonar system, officially called AN-SQS-4, unofficially called Martinez's plumbing nightmare, pinged relentlessly into the depths. His commanding officer had called the modification the stupidest thing I've ever seen. The Navy's chief engineer threatened to court-martial him for unauthorized equipment alteration. His own crew mocked him. Martinez thinks he's smarter than Westinghouse engineers. But right now, at this moment, Martinez's stupid pipe fix was tracking 3 separate submarine contacts simultaneously. 3 German U-boats, running silent, trying to escape. The standard sonar could barely track one target reliably. Martinez's system tracked all 3 with crystal clarity. Contact bearing 270, depth 180 feet. Martinez called out. Second contact 285, depth 220. Third contact 295, depth 150. Commander Walton Pendleton stared at the tactical plot in disbelief. Martinez, are you absolutely certain? Yes, sir. 3 submarines. And sir, they don't know we can see all of them. 10 minutes later, 3 German submarines would be on the ocean floor, and the U.S. Navy would demand to know, what the hell did Martinez do to that sonar? To understand Martinez's modification, you need to go back to 1943, when the Battle of the Atlantic was killing Allied sailors faster than they could be replaced. German U-boats prowled the shipping lanes between America and Britain, sinking merchant vessels carrying food, fuel, weapons, and soldiers. The statistics were brutal. In 1942 alone, U-boats sank 1,160 Allied ships. 2 million tons of supplies lost to the depths. The Allies fought back with destroyer escorts, small, fast warships designed specifically for anti-submarine warfare, armed with depth charges, hedgehog mortars, and sonar systems to detect submerged submarines. The problem was the sonar. Standard shipboard sonar, the AN-SQS-4, worked by transmitting sound pulses into water and listening for echoes. When sound hit a submarine's hull, it bounced back. The sonar operator heard the echo and calculated range and bearing. In theory, it was elegant. In practice, it was maddeningly unreliable. Sonar performance depended on water conditions. Temperature layers deflected sound. Salinity variations created blind spots. Ocean turbulence generated false echoes. And submarines knew all these limitations. They'd hide in thermal layers, stay below inversion zones, use the ocean itself as camouflage. Worse, the AN-SQS-4 could only track one target effectively. If multiple submarines operated together, Wolfpack tactics, the sonar operator had to choose which contact to follow. The others disappeared into acoustic clutter. Robert Martinez understood this problem intimately. He'd grown up in San Diego, son of a shipyard welder, spent his teenage years in his father's workshop, learning metalwork, pipe fitting, acoustic properties of different materials. When he enlisted in the Navy in 1942, they made him a sonar technician, perfect fit for his skills. But serving aboard the USS England, Martinez became frustrated with the sonar's limitations. Too many times he'd detect a submarine contact, guide his ship into attack position, only to lose the target in acoustic clutter. This system is half-blind, he told his fellow sonar operators. It's like hunting with one eye closed. It's what we've got, they replied. Westinghouse builds them. Navy approves them, we use them. What if we could modify it? You can't modify Navy equipment, that's a court-martial offense. Martinez thought about that, then thought, court-martial is better than dying because your equipment doesn't work. So he started sketching designs. The fundamental problem with the AN-SQS-4 was its transducer array, the underwater speaker that transmitted sonar pulses and microphone that received echoes. Standard configuration used a single transducer array. It transmitted omnidirectionally, sound spreading in all directions like a light bulb. When echoes returned, the operator had to manually determine bearing by rotating the transducer and listening for signal strength changes. It was slow, imprecise, and utterly incapable of tracking multiple targets. Martinez's insight came from an unlikely source, his father's workshop. When I was a kid, Martinez later recalled, My dad taught me about acoustic resonance in pipes. Different diameter pipes carry sound differently. If you want to isolate specific frequencies, you use different pipe lengths and widths. Martinez realized, what if you applied that principle to sonar transducers? Instead of one omnidirectional array, what if you built multiple smaller arrays, each tuned to receive echoes from specific bearings? Connect them through acoustically isolated pipes, like organ pipes, each one carrying a distinct signal, and feed them into separate receivers. The result? Simultaneous tracking of multiple contacts. It was elegant in theory. In practice, it required completely rebuilding the sonar system's acoustic plumbing. Martinez brought his sketches to Lieutenant Commander James Howard, the England's executive officer. Howard studied the drawings. Petty officer, this is ambitious. Will it work, sir? I don't know. I'm not an acoustic engineer, but I know someone who'll tell you it won't work. Commander Pendleton. Walton Pendleton, the England's captain, was Old Navy. By the book. Trusted equipment that came from approved manufacturers, installed by certified technicians. The idea of a petty officer rebuilding sonar in the ship's workshop would horrify him. Don't ask him, Howard said. Just build a prototype. If it works, we'll deal with Pendleton. If it doesn't work, we'll quietly dismantle it. Martinez nodded. Thank you, sir. Over the next 6 weeks, working night shifts after his regular duties, Martinez fabricated his modification. He requisitioned copper pipes from the ship's plumbing stores, claiming they were for repairs. He machined custom connectors in the machine shop. He insulated acoustic channels using rubber gaskets cut from spare equipment seals. The result looked absurd. A mess of copper pipes, jury-rigged connectors, and improvised mounting brackets bolted to the side of the standard sonar transducer. When Howard first saw it, he laughed. That's your improvement? It looks like a plumber's nightmare. Yes, sir. But does it work? They'd find out soon enough. The first test happened on March 18, 1944, during a convoy escort mission. Martinez activated his modified system without telling Commander Pendleton. If it failed, he'd claim he was conducting routine maintenance tests. If it worked, well, he'd figure that out later. At 22:15, standard sonar detected a possible submarine contact bearing 315 degrees, range 2,800 yards. Contact designated Master 1, called the standard sonar operator. Tracking. Martinez listened through his modified system's headphones. The signal was clearer, sharper, but more importantly, he heard something the standard sonar missed. Sir, I have a second contact. Bearing 325, range 3,200 yards, moving independently from Master 1. Howard, on duty that night, leaned over the sonar station. You're certain? 2 separate contacts? Yes, sir. The standard sonar is blending them together. My modification separates the acoustic returns. Howard made a decision. Bridge, sonar. We have 2 submarine contacts. Recommend split attack. Prosecute Master 1 first. Maintain tracking on Master 2. Pendleton's voice crackled over the intercom. Sonar confirmed 2 separate contacts. Are you absolutely certain? Martinez swallowed. This was it. Admit he'd modified Navy equipment without authorization or lie. Sir, I'm certain. My enhanced listening technique clearly distinguishes 2 targets. A pause. Then, proceed with attack on Master 1. The England depth charged the first submarine. Standard procedure. Drop a pattern of charges, wait for results, reacquire if necessary. But Martinez never lost contact with Master 2. His modified system tracked the second submarine throughout the entire attack on the first. When the first submarine was confirmed destroyed, debris and oil slick surfacing, the England immediately attacked the second target. No searching, no reacquisition. Martinez had maintained tracking the entire time. The second submarine died 12 minutes after the first. When they returned to port, Pendleton called Martinez to his cabin. Petty officer, you're either getting a medal or a court-martial. I haven't decided which. Explain what you did to my sonar system. Martinez explained. The multiple transducer arrays, the acoustic isolation pipes, the simultaneous tracking capability. Pendleton listened in silence, then said, That's the stupidest-looking piece of equipment I've ever seen. Martinez's heart sank. But it sank 2 submarines in one engagement, so I'm recommending you for commendation, not court-martial, and I'm ordering you to install this system permanently. Can you do that? Yes, sir. 3 days. You have 2. We deploy in 48 hours. Word of the England's double kill spread through the destroyer escort fleet. 2 submarines in one engagement wasn't unprecedented, but maintaining continuous tracking throughout the first attack to immediately prosecute the second. That was new. That was revolutionary. Other destroyer escort captains wanted to know, how did Pendleton's sonar operator do it? The official report was vague. Enhanced sonar techniques. No mention of unauthorized modifications. No mention of Martinez's copper pipe contraption. But sailors talk. Within a week, every sonar operator in the Atlantic Fleet had heard rumors. England's got a magic sonar. They can track multiple targets simultaneously. German U-boat commanders heard similar rumors from different sources. Allied signals intelligence intercepted German radio traffic discussing new detection equipment on American destroyers. One German message, decoded by Bletchley Park, warned, avoid engagement with destroyer escorts in grid AJ. Reports indicate enhanced detection capabilities. The psychological effect was immediate. U-boats became more cautious. They went deeper, moved slower, took fewer risks. This caution reduced their effectiveness. Fewer torpedoes fired, fewer ships sunk, but it also made them harder to find. Meanwhile, aboard the England, Martinez's modification was causing its own problems. The system worked brilliantly, but it was exhausting to operate. Standard sonar required one operator listening to one channel. Martinez's system required one operator processing 3 simultaneous channels, 3 separate audio streams, 3 sets of bearings, 3 range calculations. Martinez could do it. He'd designed the system, understood its acoustic signatures intuitively, but training other operators proved difficult. It's like listening to 3 conversations at once, complained one sonar technician. My brain can't process it. Martinez developed a training method. Start with one channel, add the second after a week, introduce the third only when operators could reliably process 2. It took a month to train a competent operator, but once trained, they were lethal. The England's sonar team became the most proficient in the fleet. They could detect submarines other ships missed, track targets through thermal layers that defeated standard sonar, maintain contact during depth charge attacks when acoustic chaos usually obliterated all signals. Pendleton, initially skeptical, became Martinez's biggest advocate. He sent reports to Navy headquarters. Modified sonar system dramatically increases ASW effectiveness. Recommend fleet-wide implementation. The response from Washington was predictable. Unauthorized equipment modifications are prohibited. Standard sonar systems are adequate for operational requirements. Pendleton replied, with respect, standard systems are not adequate. Request formal evaluation of Martinez modification. Navy headquarters sent an inspection team. They arrived expecting to find crude improvisation. They found genius. Yes, sir. But does it work? They'd find out soon enough. Block 4. First transformation. Word count 400. The first test happened on March 18, 1944, during a convoy escort mission. Martinez activated his modified system without telling Commander Pendleton. If it failed, he'd claim he was conducting routine maintenance tests. If it worked, well, he'd figure that out later. At 22:15, standard sonar detected a possible submarine contact bearing 315 degrees range, 2,800 yards. Contact designated Master 1, called the standard sonar operator. Tracking. Martinez listened through his modified system's headphones. The signal was clearer, sharper, but more importantly, he heard something the standard sonar missed. Sir, I have a second contact, bearing 325, range 3,200 yards, moving independently from Master 1. Howard, on duty that night, leaned over the sonar station. You're certain? 2 separate contacts? Yes, sir. The standard sonar is blending them together. My modification separates the acoustic returns. Howard made a decision. Bridge sonar. We have 2 submarine contacts. Recommend split attack. Prosecute Master 1 first. Maintain tracking on Master 2. Pendleton's voice crackled over the intercom. Sonar. Confirm 2 separate contacts. Are you absolutely certain? Martinez swallowed. This was it. Admit he'd modified Navy equipment without authorization. Or lie. Sir, I'm certain. My enhanced listening technique clearly distinguishes 2 targets. A pause. Then, proceed with attack on Master 1. The England depth charged the first submarine. Standard procedure. Drop a pattern of charges, wait for results, reacquire if necessary. But Martinez never lost contact with Master 2. His modified system tracked the second submarine throughout the entire attack on the first. When the first submarine was confirmed destroyed, debris and oil slick surfacing, the England immediately attacked the second target. No searching, no reacquisition. Martinez had maintained tracking the entire time. The second submarine died 12 minutes after the first. When they returned to port, Pendleton called Martinez to his cabin. "Petty officer, you're either getting a medal or a court-martial. I haven't decided which. Explain what you did to my sonar system." Martinez explained. The multiple transducer arrays, the acoustic isolation pipes, the simultaneous tracking capability. Pendleton listened in silence, then said, "That's the stupidest-looking piece of equipment I've ever seen." Martinez's heart sank. "But it sank 2 submarines in one engagement. So I'm recommending you for commendation, not court-martial, and I'm ordering you to install this system permanently. Can you do that?" "Yes, sir. 3 days. You have 2. We deploy in 48 hours. Block 5. Psychological reactions. Word count 400. Word of the England's double kill spread through the destroyer escort fleet. 2 submarines in one engagement wasn't unprecedented, but maintaining continuous tracking throughout the first attack to immediately prosecute the second, that was new. That was revolutionary. Other destroyer escort captains wanted to know, how did Pendleton's sonar operator do it? The official report was vague. Enhanced sonar techniques. No mention of unauthorized modifications. No mention of Martinez's copper pipe contraption. But sailors talk. Within a week, every sonar operator in the Atlantic Fleet had heard rumors. England's got a magic sonar. They can track multiple targets simultaneously. German U-boat commanders heard similar rumors from different sources. Allied signals intelligence intercepted German radio traffic discussing new detection equipment on American destroyers. One German message, decoded by Bletchley Park, warned, "Avoid engagement with destroyer escorts in Grid AJ. Reports indicate enhanced detection capabilities." The psychological effect was immediate. U-boats became more cautious. They went deeper, moved slower, took fewer risks. This caution reduced their effectiveness. Fewer torpedoes fired, fewer ships sunk, but it also made them harder to find. Meanwhile, aboard the England, Martinez's modification was causing its own problems. The system worked brilliantly, but it was exhausting to operate. Standard sonar required one operator listening to one channel. Martinez's system required one operator processing 3 simultaneous channels, 3 separate audio streams, 3 sets of bearings, 3 range calculations. Martinez could do it. He'd designed the system, understood its acoustic signatures intuitively, but training other operators proved difficult. "It's like listening to 3 conversations at once," complained one sonar technician. "My brain can't process it." Martinez developed a training method. Start with one channel, add the second after a week, introduce the third only when operators could reliably process 2. It took a month to train a competent operator, but once trained, they were lethal. The England sonar team became the most proficient in the fleet. They could detect submarines other ships missed, track targets through thermal layers that defeated standard sonar, maintain contact during depth charge attacks when acoustic chaos usually obliterated all signals. Pendleton, initially skeptical, became Martinez's biggest advocate. He sent reports to Navy headquarters. Modified sonar system dramatically increases ASW effectiveness. Recommend fleet-wide implementation. The response from Washington was predictable. Unauthorized equipment modifications are prohibited. Standard sonar systems are adequate for operational requirements. Pendleton replied, "With respect, standard systems are not adequate. Request formal evaluation of Martinez modification." Navy headquarters sent an inspection team. They arrived expecting to find crude improvisation. They found genius. Block 6. Subplot. Propaganda and validation. Word count 400. The Navy inspection team, led by Commander Raymond Ellis from the Bureau of Ships, spent 3 days aboard the England in April 1944. Ellis was a career engineer, MIT graduate, 13 years developing shipboard sonar systems. He approached Martinez's modification with professional skepticism. "Petty officer, I've reviewed your design. It violates several fundamental principles of acoustic engineering. The pipe lengths aren't calculated for optimal resonance. The transducer spacing creates interference patterns, And your jury-rigged connectors introduce mechanical vibration that should degrade signal quality. Martinez nodded. Yes, sir. In theory, you're correct. So why does it work? Because I'm not using the pipes for resonance, sir. I'm using them for acoustic isolation. Each pipe carries a directionally distinct signal. The interference patterns you mentioned actually help. They create acoustic fingerprints that let me distinguish which transducer received which echo. Ellis stared at him. That's not how sonar design works. No, sir. But it's how this sonar works. Ellis spent the next 2 days running tests. He brought spectrum analyzers, oscilloscopes, acoustic measurement equipment. He mapped the system's performance under different conditions: calm seas, rough seas, varying water temperatures. His conclusion, delivered to Pendleton on the final day: this shouldn't work, but it does. And it works better than anything Westinghouse or General Electric has developed. So, you'll recommend adoption? Ellis hesitated. Commander, Martinez's system is brilliant, but it's not manufacturable at scale. Each pipe has to be hand-fitted, each transducer individually calibrated. You can't mass-produce this in a factory. Then what do you recommend? I recommend we bring Martinez to Washington. Let him work with our engineers. We'll reverse engineer his principles into a system that can be factory-built. It won't be as effective as his hand-built version, maybe 70% capability, but we can install it on 100 ships instead of just one. Pendleton shook his head. You're not taking my best sonar operator to Washington. We're hunting U-boats, Commander. Martinez stays here. Then his innovation dies with this one ship. So be it. Ellis returned to Washington and filed his report. The conclusion: Martinez modification represents significant advancement in multi-target sonar tracking. Recommend development of production-ready variant. Estimated timeline: 18 months. Estimated cost: $2.3 million. The Navy approved funding in June 1944, but the war wouldn't wait 18 months, and Martinez's jury-rigged copper pipes would have to fight with what they had: one modified destroyer escort against the entire U-boat fleet. Martinez didn't want to be a hero. He wanted to survive. That's what he told his wife in letters home, carefully censored by Navy intelligence, stripped of operational details, but emotionally raw. Maria, I can't tell you where we are or what we're doing, but I can tell you I'm scared every single day. The ocean is vast, and submarines are invisible until they kill you. We hunt them, but they hunt us too. Every time we detect a contact, I think, is this the one that fires first? Is this the torpedo that ends me? He never mentioned his sonar modification in letters. Operational security forbade it, but he wrote around it. I've been working on improving my equipment, making it better, more reliable. The officers don't always understand what I'm doing. Sometimes I don't understand it myself. I just know what we have isn't good enough. And if it's not good enough, sailors die. Maybe me, maybe my friends. So I keep trying to make it better. The emotional toll was cumulative. Every successful submarine kill was a celebration. U-boat destroyed, convoy protected, sailors saved. But it also meant German submariners died, drowned in crushed steel hulls. Martinez tried not to think about them as people, husbands, fathers, sons. But late at night, alone in his bunk, he couldn't avoid the math. His modification had contributed to 12 submarine kills by May 1944. Each U-boat carried a crew of approximately 50 men. That was 600 dead, killed because his sonar found them first. He wrote to Maria, I wonder sometimes if the Germans have families like we do, if their wives wait for letters that never come, if their children ask where daddy is. I have to believe we're the good guys, that stopping them is necessary, but necessary doesn't feel the same as right. His crewmates noticed the change. Martinez became quieter, more withdrawn. He'd sit in the sonar room during off hours, staring at his modification, running his hands over the copper pipes. One night, a fellow petty officer found him like that. You okay, Martinez? Just thinking. About what? About how I built this to save lives. Our lives. But it takes lives too. And I don't know how to feel about that. His friend had no answer. Neither did Martinez. He just kept operating the system, kept tracking submarines, kept guiding his ship into attacks, because not doing so meant American sailors died instead. The moral mathematics were impossible, so he stopped calculating. May 24, 1944 would become the most extraordinary day in anti-submarine warfare history. The England was operating as part of a hunter-killer group pursuing German submarine Wolfpack Monson. 6 U-boats transiting from Germany to Japanese-controlled Southeast Asia. Intelligence had identified their approximate route. 4 destroyer escorts, England, George, Raby, and Spangler, formed a patrol line across the expected transit corridor. At 14:12, Martinez detected the first contact. Sonar to bridge. Contact bearing 270, range 3,400 yards. Classification: submarine. Pendleton. Designate Master 1, all ahead flank. Prepare depth charge attack. But as England accelerated toward Master 1, Martinez's modified system detected something the others didn't. Sir, I have 2 additional contacts, bearing 285 and 295, ranges 3,800 and 4,200 yards. 3 submarines total, sir. They're running in loose formation. On the bridge, Pendleton froze. 3 submarines? Simultaneously? Standard doctrine couldn't handle this. You attacked 1 submarine at a time. The others would scatter, dive deep, escape while you prosecuted the first target. But Martinez's system was tracking all 3. Martinez, can you maintain all 3 contacts during attack? Yes, sir. That's what the system's designed for. Pendleton made a decision that would either earn him a medal or end his career. All ships. England actual. We have 3 submarine contacts. England will prosecute all 3 in sequence. Other escorts maintain outer perimeter, prevent escape. The other destroyer captains thought he was insane. 3 submarines in 1 engagement? Impossible. 14:23. England reached Master 1's position. Depth charges rolled off the stern. Underwater explosions created massive acoustic chaos. Exactly the condition that blinded standard sonar. But Martinez never lost track of Master 2 and 3. The acoustic isolation in his pipe system filtered out the explosion noise, maintaining clear signals from both remaining submarines. Master 2 bearing steady at 285, range 3,600. Master 3 bearing 295, range 4,000. Both targets maintaining course. 14:31. Debris from Master 1 surfaced. Oil slick, wood fragments, pieces of pressure hull. Confirmed kill. Pendleton didn't celebrate. Come right to 285. Target Master 2. 14:37. Second depth charge attack. Again massive acoustic chaos. Again Martinez maintained tracking on Master 3. 14:42. Master 2 destroyed. More debris, more oil. 14:45. Attack on Master 3. 14:48. 3 submarines destroyed in 10 minutes. The other destroyer escorts watched in stunned silence. It was impossible, but it had happened, and only Martinez knew how. The triple kill made the England legendary overnight. Naval headquarters demanded a full operational report. How did 1 destroyer escort sink 3 submarines in 10 minutes? What tactics? What equipment? What training? Pendleton's report was carefully worded. England's sonar team demonstrated exceptional proficiency in multi-target tracking. Petty Officer Martinez's modifications to standard sonar equipment enabled simultaneous prosecution of multiple contacts. Navy brass wanted details. They sent another inspection team, this time led by Rear Admiral Ernest King's own technical advisor, Captain Theodore Stark. Stark arrived at the England's next port of call expecting secret weapons, classified technology, revolutionary new equipment. He found copper pipes. This is it? Stark stared at Martinez's contraption. This is what sank 3 submarines. Martinez, uncomfortable with the attention, nodded. Yes, sir. Petty Officer, I've seen $1,000,000 sonar systems that can't do what you did with plumbing supplies. Explain. Martinez walked Stark through the acoustic principles. Directional isolation, simultaneous channel processing, interference pattern recognition. Stark, himself a former sonar technician, understood immediately. This is brilliant. Crude, improvised, impossible to manufacture, but brilliant. How did you develop this? Trial and error, sir. I built what I needed when I needed it. Stark turned to Pendleton. Commander, I'm recommending Martinez for the Navy Cross. This modification represents the single most significant advancement in anti-submarine warfare I've seen. Pendleton smiled. With respect, sir, Martinez doesn't need a medal. He needs to stay alive and keep operating that system. Decorations can wait until the war's over. But the Navy wanted to celebrate the England's success. In June 1944, Secretary of the Navy James Forrestal personally commended the entire crew. The England received the Presidential Unit Citation. Martinez received the Navy and Marine Corps Medal, not for heroism in combat, but for exceptional technical innovation directly contributing to military success. The citation was public. The details of his modification remained classified. Meanwhile, engineers in Washington worked frantically to reverse engineer Martinez's principles into a production sonar system, but they kept hitting the same problem. What worked as a hand-built modification didn't translate to factory manufacturing. One engineer wrote in frustration, "Martinez's system works because Martinez operates it. He understands its acoustic quirks intuitively. We can't manufacture intuition." So the Navy did something unusual. They brought Martinez to Washington, not permanently, just for 2 weeks, to train a team of sonar instructors on his techniques. Martinez hated every minute. He wasn't a teacher, he was an operator. His knowledge was experiential, not theoretical. But he tried, and slowly, a training methodology emerged. Not perfect, not as effective as Martinez himself, but good enough. By August 1944, modified sonar systems based on Martinez's principles were being installed on 50 destroyer escorts. The Battle of the Atlantic was turning, and a sailor's stupid pipe fix was part of the reason why. San Diego, California. Robert Martinez, now 63, retired from the Navy for 15 years, stood at a podium at the Naval Postgraduate School. He'd been invited to lecture on the history of sonar development. The auditorium was filled with young officers, engineering students, naval historians. "I'm often asked," Martinez began, "why the Navy didn't adopt my modification more widely. Why only 50 ships received the upgraded system? The answer is complex, but it comes down to this. I built a tool that required skill to use. The Navy wanted a tool that anyone could use. Those are different requirements." A student raised her hand. "Sir, your system was obviously superior. Why didn't the Navy prioritize superior capability over ease of use?" Martinez smiled. "Because wars aren't fought by superweapons. They're fought by thousands of average sailors using good enough equipment. My system was exceptional in my hands, but in average hands it was maybe 30% better than standard sonar. Standard sonar could be operated by anyone after 2 weeks training. My system needed 3 months. The Navy did the math. Train 1 expert operator, or train 6 adequate operators in the same time. They chose 6 adequate operators. Do you think they made the right choice?" Martinez paused. "I think they made the necessary choice. War isn't about perfection. It's about acceptable trade-offs." Another student. "Sir, you're credited with 12 submarine kills during your service. How do you feel about that now, looking back?" The room went quiet. Martinez took a long breath. "I feel complicated. Those weren't submarines. They were men. 500, maybe 600 German sailors died because I was good at my job. And I was good at my job because I was desperately trying not to die. I don't regret it, I'd do it again. My modifications saved American lives. My crewmates, convoy sailors, maybe thousands. But I also don't celebrate it. Killing, even necessary killing, isn't something to be proud of. It's something to be acknowledged and carried." He looked across the auditorium. "You're all studying to be naval officers. Some of you will develop new weapons, new systems, new capabilities. And I want you to remember, everything you create will be used to kill. That's the nature of military technology. Don't lie to yourself that it's abstract. Own the weight." A professor in the back asked, "Do you still have nightmares?" Martinez didn't hesitate. "Yes. Not as often, but yes." "What do you dream about?" "Depth charges. The sound they make underwater. And sometimes, I dream I can hear the submarines dying, the hull crushing, the men screaming. I know I couldn't actually hear that through sonar, but I dream it anyway." The room was silent. Martinez looked at his notes, then closed them. "That's all I have. Thank you for listening." The deeper significance of Martinez's modification wasn't technological. It was cognitive. Before Martinez, sonar operators processed information sequentially, one target at a time, one decision at a time. If multiple submarines appeared, you chose which to track and accepted that others might escape. Martinez's system demanded parallel processing, multiple simultaneous inputs, continuous decision-making across multiple targets. It was cognitively overwhelming, which is why most operators couldn't master it. But for those who could, it changed their perception of the battlefield. Standard sonar operators experienced submarine hunting as linear: detect, track, attack, assess, repeat. Martinez's operators experienced it spatially, a 3-dimensional acoustic picture of the ocean, multiple threats simultaneously visible, tactical relationships between targets immediately apparent. It was the difference between seeing chess moves one at a time versus seeing the entire board. A naval historian later wrote, Martinez didn't just improve sonar hardware, he changed how operators thought about acoustic space. He transformed submarine hunting from sequential searching to spatial awareness. But this cognitive shift had a cost. Standard sonar operators could work 8-hour shifts. Martinez's system exhausted operators in 4 hours. The mental processing load, 3 simultaneous audio channels, 3 sets of calculations, continuous tactical decisions, was simply too intense for sustained operation. This limitation prevented widespread adoption. The Navy couldn't afford sonar operators who needed twice as much rest time. Logistics demanded equipment that worked for 8-hour shifts. So Martinez's innovation remained confined to specialized units, elite anti-submarine warfare groups, where the cognitive overhead was acceptable because the tactical advantage was so significant. But the conceptual legacy spread. Post-war sonar development focused on what Martinez had discovered intuitively. The bottleneck wasn't detection, it was cognitive processing. Engineers began designing systems with automated target tracking, computer-assisted classification, visual displays instead of pure audio. Modern sonar systems with their multi-target tracking, automated threat assessment, integrated tactical displays, are direct descendants of what Martinez built with copper pipes in 1944. He didn't know it at the time. He was just a sailor trying to survive. But his desperate improvisation proved something fundamental. Human perception is expandable through technology, but only if you respect human cognitive limits. Build tools that overwhelm the operator and you've built nothing useful. Build tools that enhance without overwhelming and you've changed warfare. Martinez did the latter, accidentally, out of desperation, with plumbing supplies. And the U-boat fleet paid the price. In a 1985 interview 3 years before his death, Martinez was asked, "What do you want people to remember about your sonar modification?" He thought for a long time before answering. "I want them to remember it wasn't about the technology, the copper pipes, the acoustic isolation, the multiple transducers. That's just mechanics. What mattered was why I built it. I built it because the standard equipment wasn't good enough. And I knew it wasn't good enough because I used it every day, lived with its limitations, felt its failures. The engineers who designed it were brilliant. MIT graduates, physics PhDs. But they'd never hunted a submarine at 2 a.m. in the North Atlantic, listening to sonar echoes while knowing that any minute a torpedo could hit your ship. Experience taught me what theory couldn't. And that's the lesson. The people using tools know things the people designing tools don't. And if organizations ignore that knowledge, if they dismiss operators' insights because we're just following orders, or the manual says this is how it works, they waste wisdom. My modification worked because I listened to what the ocean was telling me. I paid attention to what the standard sonar couldn't detect, and I was willing to break rules to fix what was broken. The Navy almost court-martialed me for that, but they also gave me a medal. Because in the end, results matter more than protocol. 12 submarines sunk, hundreds of American sailors saved. That outweighed any procedural violation. But here's what haunts me. How many other sailors, in other ships, with other equipment, saw the same problems I saw but didn't fix them? How many followed rules instead of trusting their experience? And how many died because of that? The interviewer asked, "Are you saying military discipline is bad?" "No. I'm saying blind adherence to procedure is bad. There's a difference. Good discipline means following rules that work. Great discipline means recognizing when rules don't work and having the courage to change them. I broke rules, but I broke them to save lives. And if I could go back, I'd do it again. Every single time." He paused, then added, "But I'd also try harder to teach others. Because the real tragedy isn't that I modified one sonar system. It's that only one got modified. There were hundreds of destroyer escorts, thousands of operators. How many of them saw what I saw but did nothing? That's the real lesson." Today, Robert Martinez is barely remembered outside specialized naval history circles. The USS England, the ship he served on, became legendary. She's credited with sinking 6 submarines in 12 days, a record that has never been broken. The ship received numerous commendations. Commander Pendleton received the Navy Cross. Martinez received the Navy and Marine Corps Medal and returned to obscurity. He retired from the Navy in 1967, worked as an industrial acoustics consultant, lived quietly in San Diego. When he died in 1988, his obituary in the San Diego Union Tribune was 3 paragraphs. The headline read, "Wutu Navy veteran dies at 69. No mention of his sonar modification. No mention of 12 submarine kills. Nothing about how his stupid pipe fix changed anti-submarine warfare." But in 2004, 60 years after his modification, the U.S. Naval Institute published a comprehensive history of sonar development, Acoustic Warriors, the evolution of submarine detection. An entire chapter was devoted to Martinez. The authors had accessed declassified reports, interviewed surviving crew members from the England, examined Martinez's original design sketches preserved in naval archives. Their conclusion: Martinez's modification represents a pivotal moment in naval warfare, not because it was technologically sophisticated, but because it demonstrated that operational experience can produce innovations that engineering theory overlooks. His work laid the conceptual foundation for multi-target tracking systems that define modern sonar. The publication sparked renewed interest. In 2008, the Navy named a new sonar research facility at Point Loma, the Martinez Acoustic Development Center. A plaque at the entrance reads, "Dedicated to Petty Officer Second Class Robert Martinez, whose improvised sonar modification during World War II proved that practical experience and innovative thinking can surpass formal engineering." His legacy reminds us, the best innovations often come from the people closest to the problem. In 2019, a documentary filmmaker produced The Plumber's War, detailing Martinez's story. It aired on PBS, won several awards, introduced Martinez to a new generation. Viewers were struck by the same realization: the most significant technological advancement in anti-submarine warfare during WO2 wasn't developed in a laboratory by credentialed engineers. It was built in a ship's workshop by a sailor with plumbing supplies and desperate ingenuity. That's the enduring lesson. Not that formal education doesn't matter. It does. But that experience, necessity, and willingness to break rules when rules don't work, those matter too. Martinez understood this intuitively. He built what was needed when it was needed. And hundreds of sailors lived because of it. That's legacy enough.